Let's look at homolytic fission. But before we look at homolytic fission, we talk about coily arrows. When we have a pair of electrons, we can move those two electrons from one place to another place with a double-headed arrow. This is one electron, that's one electron. That's showing the movement of a pair of electrons. And if we have a single electron, we can move that electron from one place to another place with a single-headed arrow. Coily arrow is showing the movement of electrons in a chemical reaction mechanism. Now we look at fission, and fission is bond breaking. It requires energy to break a bond, therefore fission is endothermic. There are two types of fission. One is homolytic fission and the other one is heterolytic fission. We're looking at homolytic fission. Homolytic fission, if you have a compound with similar electronegativity or same electronegativity, they will break with the help of light, because we're breaking bond, with the help of UV light to a free radical atoms, two free radical atoms, where the electron in a double bond, one going back to A and the other going back to B, because a covalent bond has one lone pair, one from A, one from B, and when we homolytically break them, one will go back to A and the other will go back to B, forming two free radicals. Let's draw it this way. This is A and that's the bond here, and that's B. And now we can see the movement of electron from the covalent bond to A and from the covalent bond to B, because A and B has a similar electronegativity and forming A radical and B radical. So these are the free radical form from homolytic fission. So what's the definition of homolytic fission? Homolytic fission is the process of breaking a covalent bond within a molecule of similar electronegativity, leading to the formation of radicals. Remember, these molecules have similar or same electronegativity. We have another example, a chlorine gas molecule, and if we use a UV light, we get two chlorine free radicals. Here's the same structure here, and we losing one electron back to chlorine and the other chlorine with a single-headed arrows, forming homolytic fission, and with the help of UV light, which is ultraviolet light, we form a free radical plus another free radical. And this is the homolytic fission.